Okay, let me make a small change in the question. Instead of selecting 1, I'll select 2. And then the question will be, find the probability, not the probability not blue, find the probability that at least 1 blue. Now I made a totally different question, right? Totally different question. So here we need a tree diagram. See, you must do a tree diagram here. Okay, so the first one selected can be blue or not blue. I'm not going to do the red and green class. It's just blue. If all what you want is blue, so that's the center of your interest now, right? So just make it blue, not blue. The probability of blue will be 2 over 10. The probability not blue will be 8 over 10. The second one selected can still be blue or not blue in both of these cases. Okay, so that means at the end what you have, you're going to have both of them blue, maybe blue, then not blue, maybe not blue, blue, and maybe both of them not blue. Okay, B bar, B bar. And I want at least 1 blue. At least 1, remember what does it mean? It means minimum 1. So which means 1 or 2. Does this has 1 or 2 blue? Yes. Does this has 1 or 2? Yes, it has 1. Yeah, does this have 1 or 2? No. So that means actually I need these 3 outcomes. So how do I get them? I just get the probability from the multiplication rule. I need to multiply this probability here by this one to get this one. And multiply this one by this one to get it, and so on. But it's really long time, isn't it? Why don't we just use the complementary rule idea to make it faster? And instead of calculating these 3, why don't you just calculate this one and do 1 minus? Isn't that faster? Because in this case, you'll have to calculate you'll have to multiply only 2 numbers to get this outcome. And because the total is 1, so you just do 1 minus. The total from here to here is 1, right? Yeah, because at the end of probability experiment, any probability experiment, if you add the outcomes, it's 1. And if this is required, this is what you're looking for. But this is easy. Just get the easy one and do 1 minus. Does it make sense? Yes or no? Makes sense. So from here comes a rule. Why? Because that's only if you selected 2. Imagine you selecting 3 or 4 or 5. That would be crazy. Right? So you really need an easier solution to this problem. So what are we trying to say here is that in this case, the rule is if I ask you about the probability of at least 1 blue, the answer is 1 minus the probability of what? What is this one? Both of them are not blue. So that means the probability that all are B bar. So that's another rule. That's another rule. The probability of at least 1, anything you want, this only for the at least 1. This does not include at least 2 or 3 or 4, or just for the at least 1. The probability of at least 1, anything you want, is 1 minus the probability that all of them, the opposite of what you want. The complementary of what you want. You want at least 1 blue, just get the probability that all of them not blue, and then do 1 minus.
Select 2, why is it there?
Why is it what?
It's completely select 2. Select 2 should be select 2.
I selected 2. This is the first selection, could be blue, not blue. Second selection, blue, not blue. Every stage is a selection, right? If you select 3, there will be 1 more here. If you select 4, there will be 1 more here. And then I want at least 1 on the outcomes.
How do we continue this?
We continue this, we just get the probability here, which is 8 over 10, which is already, we got that. Imagine B bar. Suppose the first one not blue. What will be the yeah, exactly, the remaining is 9. So we'll be dividing something by 9. What is by 9? 7, yes, because there were 8 not blue. You took 1 already. So remaining 7. We did this before in the previous classes. You just reduce up and down. So that means this probability we're looking for here, in this case, will be actually 1 minus 8 over 10 times 7 over 9. And you just need to multiply these 2 numbers first and do 1 minus after that. Okay?